my name is Ciro Continisio, as he said. I'm coming from Unity, the Unity office of Brighton in the UK. And I want to give one little disclaimer, because this presentation is titled Getting Started with the SRPs, the Scriptable Rendering Pipelines. But I'm going to be focusing a lot on the lightweight rendering pipeline, the one for mobile, the one for any PC, any console. If that is your interest, stay. If you're more interested in HD rendering pipeline, the one that we used for the Heretic, if you've seen the keynote, the ray tracing demo, and high-level, powerful rendering, realistic rendering, there's a talk happening right next door. So just to give you a disclaimer, I don't want you to see the wrong presentation. I don't want you to be disappointed. So Ashley is giving a talk on HD rendering pipeline next door. If you want to leave, I'm not going to be offended. I will remember your faces, though. So. But if you want to stay, let's start. So I want to give a brief introduction on why we created the SRPs, the problems we were trying to solve when we made this technology. So the problems are, in Unity, we see different art styles and different rendering needs. Like you folks, you make like games and applications that are quite different, quite distinct visually. So some games are for realistic, some others are stylized. Some games require no real-time lighting, while others require a very complex real-time lighting setup. So, and on top of that, we want to help developers maximize their reach by going on different platforms. So we always had this, what we now call the built-in rendering pipeline. The problem is that providing a single rendering solution that's optimized for all of these scenarios is hard, and it's becoming harder and harder. And we have also some legacy code that comes from like 15 years ago when Unity was first created. And the pipeline being all in C++ means that it's basically deeply rooted into the engine. So each new feature that we develop requires that we make sure that it works on all of the supported platforms. There's no performance regression, and this is becoming harder and harder. So with the built-in pipeline, we got to a point where all of this is becoming impossible. And so we decided to come up with a new solution. And we made this technology the Scriptable Rendering Pipeline, or SRP in short. So Scriptable Rendering Pipeline is a high-level description of rendering, all written in C#. So it interfaces with C++, but it's detached from it. And it's, I say high-level, so you only see a certain amount of options, let's say. And because it's C#, we were able to release the code open source on GitHub. So you will find it at this address if you want to investigate, if you want to read it. And actually, when you use an SRP, whether it's HD or lightweight rendering pipeline, because it's C# and because it's a package, this new way of distributing features that we have, you will actually find this code in your project in the packages folder. So you're able to read it, you're able to modify it and stuff. So if you're a graphic developer, if you're a graphic programmer, is there any graphic programmer here today? 2, 3, 4? Some of you? You can also put your hands in the code and modify the pipeline to your liking. But because we're not sadists, for the majority of use cases, we also provide 2 SRPs ready for use, which are the lightweight rendering pipeline and the HD rendering pipeline. So just to give you a very, very quick overview of the HD one, I'm going to spend only one slide of this, as I said. HDRP is our high-end pipeline. So it's the one that enables like 3D next-gen graphics. I always say that it's very future-proof, meaning that not everything that will be invented in the next few years comes to like lightweight, but HD is the one where like all of the new techniques, all of the new rendering techniques will end up happening. In fact, ray tracing is part of HD. So in HD rendering pipeline, you will find all the things that you can possibly desire. Multiple rendering techniques, deferred and forward, working together to address different effects. It handles transparency perfectly. And refraction. It has a built-in solution for volumetric lights, decals. It has multi-layered materials that look incredible. It has subsurface scattering for like skin, and it actually comes with a skin shader already made, and in the future it will support hair. So for now you've seen the hair shader for the heretic, for like eyebrows, but in the future it will support like longer hair workflow. And we have used the HD rendering pipeline ourselves, like Unity, to create impressive demos like Book of the Dead, which is this one, the FPS sample game, if you've seen it. Mega City runs on the HD rendering pipeline. And of course, the Heretic, which Andy has shown this morning in the keynote. But this pipeline is expensive. It doesn't run everywhere, and it requires compute shaders to run. That's why it can't really go on every type of hardware. So for this reason, it's more adequate for high-end PCs and high-end consoles, while, as I said before, for all the other uses, there's lightweight rendering pipeline. So lightweight rendering pipeline is, as I said, an all-purpose pipeline. It goes on from like low-end mobile to high-end mobile, low-end PCs to high-end PCs, and all consoles, including the Switch. We call it lightweight, and I know that the name is a bit misleading, so don't think that lightweight means terrible or bad-looking. Lightweight means that it runs fast. But I always want to reiterate that lightweight rendering pipeline today, it does like 85% of the things that the built-in pipeline used to do. So you can do pretty much like all that you used to do before. For 85% of the games and apps, you can probably migrate and obtain the same look, and it will run better. So the name can be a bit misleading sometimes. So lightweight rendering pipeline is another scriptable rendering pipeline built on top of the core SRP APIs. It's been developed from scratch with performance in mind and with mobile in mind. So it means that we thought of mobile first, but then we also wanted it to be, as I say here, scalable between different platforms. So as you make a game that maybe runs on mobile but also on PC you will be able to use more capabilities almost automatically, and it will just look better. And because it's all new, we managed also to squeeze in a lot of improved workflows and extensibility, so a lot of improvements on the user experience. So as you work, you will be faster. And the good news is that it's out of preview in 2019.1. So if you're using 2019.1, you download the package, and that's a version that you can probably start using for your projects in production right now. How do you get the lightweight rendering pipeline, but also HD, so both SRPs? You can get them by templates. Templates are the things that you see when you start a new Unity project. There's a drop down there that looks like that. And when you get them through templates, you get some assets that demonstrate like a simple setup with the pipeline. So you get this example scene that contains like, reflections, baked lighting, so a series of things that you will probably want to do with the pipeline. This goes for both a lightweight rendering pipeline and HD. You can get the pipeline through Package Manager, and that's a very good way if you have a project that's already going and you want to migrate. So you open your project, go to the Package Manager, and you download the SRP, the lightweight rendering pipeline, through that. That's good if you're switching. So that's how it looks like, and Package Manager, of course, allows you to quickly update it if you need it. And then another little bit of a hacky way is to change the manifest. And by changing the manifest, so this text file that you get in the packages folder, the advantage with this one is that you can redirect the location of the pipeline anywhere. So that potentially allows you to grab our code, our source code from GitHub, drop it in a folder, then point your project to that, and then in the future you can like pull changes from us, but at the same time you can make yourself some changes, and then you can merge them. So you can get both our fixes with your customization. And hopefully it's going to be easy to merge. That depends on like how much you customize it, of course. So only for the pros. So briefly talking about the increase in performance, I just want to show you that lightweight rendering pipeline runs faster than built-in, basically. We did a lot of testing around these areas, fill rate, draw calls on the GPU, how draw calls are handled by the CPU. Because, like some people might think like, oh, because it's in C#, it's gonna tax the CPU more than the built-in. But actually, we worked a lot on that and bandwidth. And if you wanna test this, use this test yourself, you can find it at this location. It has this silly name, Potato Benchmark. It wasn't mine. But if you wanna grab it, it's there. And in general, for all we do, Unity-Technologies is the main repo, is the main organization on GitHub where you will find all of our repositories. If you use the one without the hyphen, you will land on the evangelism one, which is where we put our terrible stuff. But the serious stuff is on this one. A test with multiple point lights. You can see how Lightweight Rendering Pipeline bits built in with all of the major graphic APIs. These are roughly, the speed improvements per frame. Draw calls on the GPU. This data, so this scene has a decent amount of triangles and 4 shadow map cascades. This data is actually a bit old, so you will see the GL-ES3 is not that faster. I know Metal is also not faster, I don't know why. But for example, for GL-ES3, there was a little bit of a bug that we already found and fixed, so this data is actually old. And I want to point out because with the cool thing with SRPs is that because it's a separate module and it's like being rewritten, we're able to push fixes much, much faster. So in the past, some things in the built-in pipeline were hard to fix because we were like deeply rooted into so many platforms and also like legacy platforms. And now because this is new and detached, we're able to iterate much faster. And also when we push a package, we're able to deliver it to you faster because as soon as that package is ready, we can just like put it on the server and you open the project and magically you will see an update. A batching test where we render 2.7K objects, all with different materials. This tests the CPU to check the cost of batching and the cost for each set pass call. You might see there's a difference in the images, but that's because the color of the materials was generated procedurally, so some of them are too saturated. Bandwidth intensive test. I don't want to bore you with like these boring numbers. Draw calls have been improved. So basically, Lightweight Rendering Pipeline is able to batch more materials together, and I'll show you why in a second. So the draw call number goes down. So this is Angry Bots 2, one of our historic demos, second version, and we migrated it from built-in to Lightweight Rendering Pipeline, trying to achieve the same look. And you can see that it uses almost half of the draw calls. The reason for that is mostly because of this new batcher that we got, which is called SRP Batcher, very, inventive name, which works actually on both lightweight and HD. So it's a technology that's underneath the two pipelines. And in short, this new batcher, what it does is makes good use of the concept of persistent data on the GPU. So it's something that we couldn't implement before because we were tied to old graphic APIs like DirectX 9 and stuff like that. But because we moved on now, we were able to use this concept. So the idea is that before, there was a lot of data that Unity's rendering was setting per material every frame on the GPU. So it was like passing this data every frame. And so making a new material will break a batch because Unity had to set this data separately for that one new material. And now, with this persistent data, we're able to send some data once and keep it there on the GPU while we send some other data per frame. All the materials that use the same shader will basically make use of this persistent buffer. That's why less draw calls and stuff. So the data only needs to be re-uploaded if you change the material. If you change some property of the material, then Unity re-uploads it once and then keeps reusing this buffer again. And this frees a lot of work from the CPU, making sure that the rendering loop generally runs faster, and it allows you to worry less about creating a new material. You know how before you had to go like, oh, if I just change the material, that's going to create a new draw call, so I want to, pack some textures together and do some trickery. Now you can worry less about that. To enable the SRP Batcher, you just need to go into the Lightware Rendering Pipeline asset and tick a checkbox. So the default shaders provided with SRP all work with it, and also the ones that you make with shader graph. Currently, it works on these platforms. So you see Metal and DirectX 11 support Mac and Windows, Vulkan as well, and then PS4, and then it's going to come soon on these other ones. And to see if a shader is compatible with the Batcher, all you need to do is to select the shader, and in the inspector you will see this one line. And if it's not, Unity will just default to the regular Batcher that we had before. So some objects like skinned mesh renderers, objects drawn with material property blocks, some of these objects are not compatible with the new SRP Batcher. And if you plan to write your own shader, all you need to do is to declare these properties in a buffer called Unity per material. And then the shader will be magically compatible with our new SRP Batcher. There's a huge blog post, by the way, on this subject, on this Batcher and on the way how you write custom shaders for it. That's on the blog. So if you search for SRP Batcher, you will find it. There's a lot more information that I can provide now. Another thing that SRP brings is improved workflows. So I'm not checking my messages, I'm checking the time. Because I forgot to start the time here. So the biggest improvement, I would say, is shader graph. And shader graph is a feature that people have requested for a long time, a node-based shader editor. So the SRPs support that. And by the way, only the SRPs. So shader graph is not compatible with the built-in pipeline. For the reason that I told you before, like there's so much legacy stuff that we can't really support it for both worlds. Because of course shader graph comes, with like shader templates. Each template has to be for a different pipeline. So keep doing the work for the built-in is unreasonable. So shader graph is an artist-friendly tool. It enables quick iteration in creating shaders. So while you still don't even know where you're going with your shader, then shader graph gives you that speed. The cool thing is shader graph actually creates code at the end of the day. So, and that code is very readable. So if you right-click on the master node and you select show generated code, you will see the actual final shader. And so for that reason, you can do several things. First thing, you can read it and see what it's actually doing, how it's doing it, if you like it or not. If you're a graphic programmer, you can actually modify it. So you take that code, you drop it in a text file, you modify it, save, and that shader is ready to use again. The only thing to keep in mind is that that workflow is one way. So if you modify the shader in text, you can't really reconvert it back into a graph. So it's a one-way process, meaning that if you have a big pipeline, you have artists creating shader, then you can pass the shader through a final cleaning process. So giving the text to a graphic programmer, they clean it, and then it's ready to go. It's a possibility. If you're doing something very complex, you want to optimize one section of the shader, it's something you might do before release, for instance. The other cool thing is you can code your own nodes. So as you work with shader graph, you can also have a node which is called, I always forget the name, custom function node. And that node allows you to put some HLSL code into a node with like entry ports and exit ports. And then you just drop it in the graph and you use it as any other node. So that allows you to create your custom stuff. That allows you to create something that maybe you want it to be performant in a specific way. You can do that. And then you give that to artists, and they keep iterating fast, but with your custom code. And in the future, we will allow to create full-screen post effects as graph. This is not there yet, but we're getting there. As I mentioned before, we brought a lot of small quality of life improvements to SRP. So even on the regular standard shader provided with Lightware Rendering Pipeline, you will see a lot more options that allow you to tweak your materials more than before, like the ability of choosing front, back faces, or both. You have more control on blending, you have more control on sorting and priority. And this is standardized across all lightweight rendering pipeline shaders. Some of these controls also on shader graph created shaders. It's easier also to get the camera depth and the color of the scene. So you can use those two textures to create your own effects. You literally just need to enable them on the asset that controls the setting of the pipeline, and they will be available to you to use in your code, even C# code, I believe. But if you're using shader graph, you can literally just drop a node in the graph, and then you're able to use these two textures to create your own effects, like refraction, fake refraction stuff, like here on this water, and stuff like that. SRPs come with a refreshed and improved view of the rendering loops in the profiler and in the frame debugger. So everything is clearer, more readable, is better organized, basically. And you can see here how the structure of the loop is clearly readable. Every step is separated from the others, and you can see what's actually going on. And I want to comment on this, saying that probably an untapped potential of these technologies that if you're studying graphics programming, or if you're teaching graphics programming, then you could potentially use Unity kind of as a sandbox. So because now with the SRPs, you also have the source code. So you can say, studying, like a pipeline, how it works, studying how to write a shader, maybe using shader graph to create your first shader, and then looking at the code and see how that shader is made, make a modification and see how it is changed. You can do a lot of stuff. And then with these tools, you can then see how the frame is actually composed. I don't know if you've ever tried the frame debugger. Has anyone tried it here? Okay, some people, but not everyone. So it's a relatively not hidden tool, because it's been there for more than a year. So I'm checking my messages again. It's very useful because it shows you how the frame is composed, step by step, and which textures are being used, which buffers are being read, and also why some batches of draw calls are being broken and stuff like that. So it gives you a lot of information. So it's great for learning and teaching. And finally, another cool thing about SRPs, and especially lightweight rendering pipeline, is customization. So as I mentioned before, all games have different needs. So we wanted to enable that very quickly and very easily. So we have this new thing that's in the recent versions of the. Sorry, I just noticed that I have the time here, so I don't need to check the phone. 15 minutes. So yeah, this allows you to customize the rendering better. It comes with the recent versions of lightweight rendering pipeline. And basically what it is we say that the renderer can be extended with custom features. So you will see in the asset, there's a section where you can connect these other assets, and the other asset allows you to create a list of custom passes. So in short, what this does is you can decide to render some objects in a different way. First, you group them by layer. So you create a layer, you put those objects on a layer, in the editor. Then you go to this asset, and you create a list of these render features, which can do many things. They can execute command buffers, they can draw objects, and modify their depth or stencil artificially. They can draw them with a different material, and much more. So we provide a few pre-made of these render passes. Sorry, of these, we call them features. But you can also program your own if you want, and then you insert them in this list. The features that are by default in the project will appear. Sorry, this is what you can do with it. The features in the project will appear in the drop-down on the plus icon. So as you add them, if you create custom ones, you will see them there, and then they end up in this list, and then they will be executed as part of your rendering. To give you an example of what you can do with this stuff, a classic one is outline effects. So the idea of drawing the mesh and, or better, drawing the outline and then drawing the mesh on top, so you see like a line running around it. That's usually done with 2 passes. So custom render passes allow that. And this has to be based on depth, right? So you can do that easily without code. And you know, the cool thing is you can add it to any shader that you have. So you don't need to modify your shader, but you add the pass, and we modify the shader for you. Still an additional call, and I'm not saying that we save on that draw call, but you don't need to change the shader. Occlusion effects, like the idea that you have a character or an object that's behind another object, and you don't see it, but you see its silhouette, or you know, you see its visibility somehow. Like here, you can see it on the unit here that's behind the tower. That effect, like how you draw that character on top of the tower, you can decide. You can use another material, you can make a new shader with shader graph, and through these customized render passes, you can obtain that effect. Another classic effect is custom FOV on some objects. So for shooters, this is really useful. For instance, you want the weapon to be a different field of view from the background, because normally in shooters you want to give like maximum visibility, so you exaggerate the field of view, but then the weapon looks stretched on the side, so you need to adjust it somehow. And in the past you will do this with 2 cameras with different field of views. And the sad news is that Lightweight Rendering Pipeline doesn't support multiple cameras yet. They will arrive, but like later on. The good news is that with this thing, you can just do it with 2 shaders. So you even save performance, actually. So from bad to, to good. But there's more. So with Lightweight Rendering Pipeline, we have this concept called the renderer. And basically, the renderer is like, to put it in very simple terms, there's some data preparation that the pipeline does. And then there's some final operations that it does to render things on screen. And these final operations, the renderer, is something that you can actually swap in the Lightweight Rendering Pipeline. And it's similar to the built-in, you know, when you selected like forward or deferred or legacy vertex lit, I think it was called. So for now, Lightweight Rendering Pipeline only has a classic forward renderer. There is a single pass light loop with supports for up to 4 pixel lights, and it's very optimized for draw calls, and as I said before, an overdraw. But in the future, we want to add more. So one that is coming up really fast is the 2D renderer. The 2D renderer, of course, is specialized for 2D, so it doesn't give you the ability to mix like 3D and 2D. But what it does is that it's super optimized for 2D, so 2D will go like crazy fast. And it brings you the ability to have the 2D lights. Don't know if you've seen any presentation about this. I think we've shown it at GDC. 2D lights are basically the concept that the light is not in 3D space, but is exactly on a plane. So you don't need to care where you're placing it in 3D. You don't need to care about the Z depth. And it doesn't produce like weird artifacts. But it's almost as if it was like a blending layer in Photoshop with a shape that you can define. And then you decide the blending. You can choose like overlay, multiply, and all the many blending styles that you have in Photoshop. But the coolest thing, I think, is the custom shape, and then you can fade on the silhouette. So they're really cool, and you can overlap them and stuff. So the 2D renderer brings that, and it brings also pixel perfect, so a lot of quality stuff that you need for 2D games. And this is coming in 19.2. So around 19.2, you will see this option for Lightweight Rendering Pipeline. And then by 19.3, we want to bring back the deferred renderer because people have been asking for that. And so by that time, basically, Lightweight Rendering Pipeline and the built-in pipeline will have reached feature parity. So all you could do with the built-in pipeline, now you can do it with lightweight plus more. You know, plus you will have shader graph, you will have the 2D renderer, you will have more optimization, and all of that. So there will be basically no reason to consider staying on the built-in pipeline. So later this year. I'm almost at the end of my talk. I want to leave you with one key takeaway. So SRP, and especially with Lightweight Rendering Pipeline, they provide you plenty of options to get the look you want in an easier way. But you have several options, so I want to bring some clarity to it. And I made a list from the easiest to use to the more powerful. So the easiest to use, of course, is to use Lightweight Rendering Pipeline as it is. Download the package and you start messing with the shader, with shader graph, so you don't need to code shaders and stuff like that. And you get like a decent amount of customization and performance. Then you can dive deeper and you can start using the custom render passes, as I've shown you, that list of passes that you can customize and reorder and change the depth and stuff like that. It's added level of complexity, but still no code. And then you can start customizing and tweaking the rendering the way you want. Then you can start to code, and you can script your own custom render passes and add to that list. So do very specific things that you like, but still within the context of Lightweight Rendering Pipeline. So you just add an extra pass that does something special. Then you can go bananas. You can implement your own renderer. So you know how I talked about forward, 2D, and deferred? You can potentially create your own renderer that does like things the way you want. I haven't dived into that. I don't know what all the possibilities are there, but that really allows you to customize lightweight. Yeah, the thing I want to point here is that you might say, so if I'm creating my custom renderer for Lightweight Rendering Pipeline, why don't I make my own custom SRP? So the point here is that just implementing your own renderer is way easier than creating a whole SRP from scratch. Lightweight Rendering Pipeline will solve some of the issues for you, like figuring out targets for the rendering, figuring out stereo rendering for VR. So if you want to make your pipeline for VR, Lightweight already does that, and it does it for you. Or editor rendering, for example, the gizmos or the selection outline. That's something that if you make your own custom SRP, then you will need to do some work to reproduce it. While if you just create a renderer for the Lightweight Rendering Pipeline, then all of that is already done. So it's easier. And of course, the fifth option will be to build your own SRP from scratch. So you skip Lightweight completely, you skip HD completely, and you just go to the core SRP API, and you build your own on top. And I have a friend, he's created 2 of them, and using them in production, so it is totally possible. But that's really when you want to control like the whole process. And last thing I want to point out is that in this progression between from easier to harder, as you move between the first 3 steps, you can basically go back and forth. So you can go using a Lightweight Rendering Pipeline, maybe customizing with some custom render passes. Then you don't like the look, you want to go back and you remove them. Or you script your own, you don't like them, they don't work, they don't perform on your hardware, you remove them and you go back and you try to figure out a different way to obtain the same look. But as you move in, towards like points 4, number 4 and 5, you're venturing into a territory where you're making, well, of course you're making a lot of work first. Second thing is you're probably authoring your assets to cope with that solution. So if you go back, then you will need to like swap materials, swap shaders, so there's a lot of work involved in that. So if you go to points 4 and 5, you're really like going down a route where backtracking is a bit hard. So, if you're like 2 years into production, at that point, switching back is almost impossible. While if you're 2 years into production and you're between like points 1 and 3, you can still like wrestle around and change the passes and nothing will really break. So I hope this is my takeaway for this talk, to give you an idea of how flexible the pipeline is, of all the possibilities you have at your disposal. And with this, I'm basically done. So if you have questions, this is the time. You have one question there. I think he's gonna give you the microphone.
So this is like a shader graph question.
Mm-hmm.
So with the custom code node for that one, do you have to like produce multiples if you want to be calling the same function like multiple times? or can you script it out entirely for a custom code?
I'll show you.
Release it?
I'll show you one example. Have you ever used it?
Little bits. Just when it was first released, it was pretty basic, so I kind of gave it a pass.
I have a project here made with LWRP rendering pipeline, and I made a custom shader, a custom toon shader. Actually, I made two of them. One for real-time objects like this tower, because the tower has to be destroyed. So you see the shadow here is actually real-time. In fact, if I move, it moves. One for these objects which are baked. You see the shadows on state. And to build this shader, because I wanted to grab the lighting, I've actually made some custom code. And if I look at the shader, it's here. Royal Toon, yes. So this is the shader, and this part you can see is disconnected, so it's actually not important. This is the actual shader. The custom lighting function is in here. This is a subgraph, so I basically encapsulated the node into a subgraph, so I can dive in. And this is the node that I coded somehow. So you can see that this one points to a file, right? So that file defines the code, and then in here I define the outputs, and they have to match. Once I have this node that I can use and reuse. So in my graph, I'm gonna go back. In my previous graph, I have this node, and then I can like create node, custom lighting, and I can reuse it again. Does that answer the question?
Yep.
Okay. So yeah, you make it once and then you reuse it several times. And because it's the same one, in the code, in the text, it will actually be the same text. So Unity recognizes, of course, that it's the same function, and it will run different inputs into the same function to generate the outputs. So this basically becomes kind of like a function code, and I want to show you because I have probably 1 minute or 4 minutes. I just want to show you the produced code. So if I go here to the master, as I said before, show generated code, it should work. So you see the shader here. Now this is, I think this is the final shader, but let me do one thing. Copy shader. Yeah, okay, so this is the plain text. Yeah, so this is the shader. So here you could see what shader graph is actually doing. So you see, for example, a multiply node. Can you read the text? A multiply node becomes this function. Input, 2 numbers, output, a third number. And all that you do becomes this. So you're really able to inspect like what's going on. And somewhere here there's the code that I wrote for this custom node, which if you want to see, it's exactly this one. Shaders, function. Can I do this? Yeah, so this is the code that node contains. Input, output, output, output. And that's why that node looks like it has 3 outputs here and 1 input. So as you can see, it taps into the pipeline code. And that's why I said before, like when you don't build things from scratch, and even in this case, it's probably just tapping into the core SRP API, you get all this function that you can just like grab the lighting, grab the shadows, and then you do what you want with it in your shader. Okay, I think I need to go because I don't know if there's another talk now, and I need to disconnect my computer and leave space. I hope you enjoyed the talk. And if you want to ask me questions, I'll be around, I'll be outside. Thank you.